Hi everyone, we're on to chapter 2 and we're looking at patterns and cycles in the sky. Now, I could talk to you about directly from chapter 2, but in my opinion, the chapter is all over the place. So I am going to prepare my videos from a chronological perspective, showing that these very intelligent people that preceded us had accurate observations, then they could measure these observations and they could report them. They didn't analyze them for the reasons why, they just accepted them. And over time, the scientific method helped them to look at the reasons why they were seeing what they were seeing. But we're going to start very early, and I think you'll be very impressed by the intelligence of your ancestors that preceded you, who worked with very few instruments and did very accurate measurements of the nightly sky and the daily sunrise and sunset. These ancestors of yours are all over the world. They are in Africa, they are in the Middle East, they are in Europe, they are in Asia. All of these people were studying the sky in order to make sure that they could arrive at the water source that their ancestors may have found on the date that they knew there would be water there because of flood patterns and monsoon patterns. They were timing animal migrations. They were timing their planting later when they started to become farmers. So all of these ancient people independently assumed that the heavens rotated around the earth, which is really remarkable because obviously they were not talking to each other and they all had the same assumption. That applied to not only the sun during the day revolving around the earth as they saw it, but the moon, the stars, the planets, the meteors, the comets. They saw them all and they observed and recorded them all. In many cases, they ignored some of the accurate observations that conflicted with their thought pattern or their paradigm that said that the earth was the center of the universe. They just put that aside. And they devised some really incredibly complicated explanations. One of them is over to the right there that looked at spheres around the earth. Some of the latest observations of this that go to the 1600s, I believe, have 27 spheres of sun, moon, planets, stars, meteor showers, comets that go around the earth in these unbelievably complicated patterns because they wanted to preserve the thought pattern or the paradigm that said that the earth was at the center of the universe. Now we know, and we can approach it from our point of view, that that's not the way things happen. And in fact, what they thought was elegant and simple, that the earth is the center of the universe, but that got much more complicated, is actually a little bit more complicated, but very elegant. And that the earth actually moves in 3 ways at all times and at different rates. And it's simple and it's elegant, and we'll talk about what they observed and how that fit into what we know now as we explore what we know now. First of all, the earth the earth moves in 3 ways. It rotates on a daily basis. It takes a 24-hour turn. It revolves and takes a lap around the sun every year. And what you might not know, it wobbles. And the wobbling is called precession, and it was actually figured out very early on, but we'll go there in a few minutes. Later in the 1400s, 1500s, 1600s with the Renaissance, we finally started to move into this idea of the earth rotating in 3 ways, but we're not the earth moving in 3 ways, but we're not even going to get to that until the next chapter. The first way, like I mentioned to you, is the rotation, the daily movement. It's from the Latin word dies for day and it's called diurnal motion, for dies day, diurnal motion, the rotation. The revolution is the annual motion of the Earth around the sun. And the precession is the motion of the Earth wobbling on its axis like a top. The long-term ramifications of this wobble is that the Earth's axis points in a different direction, which creates a setup for a new North Star. Let's get into that. The people had observed many of these motions, and they devised very accurate tools to measure those observations. In fact, the Egyptians back into 3000 BC had already devised a carpenter's square, and they could use that carpenter's square very accurately to measure angles in the sky. They were measuring angles of stars, of constellations, of pole stars, of planets, of the sun, and of the cycles of the moon. The phases of the moon, the eclipses of the moon, not the tides. They weren't measuring the tides, but they used these simple tools to do very accurate measurements. Now we can talk about the first observations, and the first observations that we know of go back to about 6000 BC in sub-Saharan Africa in the Fertile Crescent, which I'm sure you've heard about, the Fertile Crescent, which goes all the way from Egypt all the way over to Babylon. And that was basically the cradle of civilization at the time. That was the New York of the time, I guess. And in sub-Saharan Africa, what we found are these calendar circles. This one is called Playa Nabta Playa, and it is a megalith. A megalith is a large stone, lithography stone, that is used for astronomy. They found this one in Egypt along the Nile Valley, and it appears that these stones are set up, particularly these stones in here, are set up to look for a time when the sky would line up the stars with what they saw as the god of Osiris in the sky. Now you might say that's Orion's belt right there, but the Egyptians didn't look at it that way. They said this was Osiris. He was the god of agriculture. And of course, along the Nile, agriculture is very important. And in addition to that, they also ruled their calendar by this star, which is the brightest star in the sky at that time and still the brightest star in the sky now. This star to them was Septet, and she was the goddess of the Nile and fertility, and their solar calendar started when she appeared in the night sky. In the yearly rotation, when she appeared, their calendar started. That's how important she was. So they are wondering if this is Osiris's belt and this is Septet. And when the stars lined up, they knew that the winter time was here and that the Nile would flood soon in the springtime, the earlier spring in Egypt, so they could get ready for planting at that time. So really very early monuments to their star observations. We talked about Septet as being the brightest star in the sky at that time. They had a very early brightness scale, and this scale has actually been maintained. This scale goes back to Egypt and was modified by the Greeks, and we've maintained that Greek scale. We've modified it a bit, but basically it starts at what's called first magnitude. like first aid, most important aid. And the larger, the smaller the number, first magnitude star is a very, very bright star. And third place, third magnitude, fifth place, fifth magnitude star, much less bright. All right, so it's kind of counterintuitive, but Septet, or Sirius, as she is known to the Greeks and the Romans, is the brightest star in the sky. It even has a negative brightness number because it is so much brighter than even first magnitude, very close to being as bright as Venus, right? So this is Sirius, that is the Roman term for that star. Septet is the Egyptian term. The Egyptians, and in fact, all of the peoples that we are talking about in this chapter, had no concept that stars could be at different distances in the heavens. It wasn't in their paradigm at all. So they believed that all stars were the same distance away. To sum up, all ancient peoples independently assumed that the heavens rotated around a fixed earth. And the heavens included the sun, the moon, the stars, the planets, the meteors, the comets, everything that they saw. They even saw supernovae and nebula forming. We'll get into that later. But they did tend to ignore observations that conflicted with what they had in their head. We're going to get into that in the next chapter about some of those conflicting observations. And just to sum up as well, they didn't understand distance measurements for stars. They had an idea of how to measure relative distance for the moon and so forth, but they didn't have a good way of measuring distances for stars. Let's get into the next video, and I'll see you there.